Hey guys, by now you should have already done your 5, 6, type 1. So we can go ahead and get started with the bell ringer. So we're going to graph this equation, y equals 5/4 x plus 3. And this equation is given us in the slope-intercept form, so it's given us in the y equals mx plus b form, where m is our slope and b is our y-intercept. So in this case, b is equal to 3. And our slope m is equal to 5/4. Since b is 3, that's going to be my starting point. We're going to start at the 3. And the slope tells us how to move, allows us to find another point. And it's our rise over run. So we're supposed to rise 5 and run 4. But since we can't rise 5, we're going to have to go down 5 and to the left 4 to get another point. So right there. And since we have 2 points, we can go ahead and connect them with a line. Now, this lesson has a lot of graphing in it, so it's important to remember how to graph something in y equals mx plus b form. So we first start with our y-intercept, and then move along with our slope, our rise over our run. So today we're going to be graphing linear inequalities. So we're going to start off by looking at, we're going to graph the solution of y is less than or equal to 3/2 x minus 2. And this doesn't look too different from what we graphed. The only thing that's different is this inequality sign. We're going to go ahead and take care of that later. But first, we're going to look at this in two different ways. We're first going to graph the 3/2 x minus 2. We're going to graph that part first. And we know how to graph that. We're given a y-intercept. We're given a slope. My y-intercept is -2. And my rise is 3, runs 2, so I have another point here. And I can rise 3, run 2 again, and get another point here. Or I can go down 2 until the left, down 3 into the left 2, and get a point there. And so this is my line that I will have. So that's the 3/2 x minus 2 part. Now we're going to look at the y is less than or equal to part of that. So we're going to do that by using x values to show where that part of our solution will be. So we're going to find out what y will be when x is equal to 1, x is equal to 4, and x is equal to -1. So whenever x is equal to 4, let's substitute this 1 into my inequality to see where y can be. So I have y is less than or equal to 3/2 times 1 minus 2. 3/2 times 1 is just 3/2, so I have y is less than or equal to 3/2 minus 2. So y is less than or equal to -1/2. So whenever x is equal to 1, so when x is equal to 1, which is right here, so at that point right there, x is equal to 1, y is less than or equal to -1/2. So y is going to be less than that part right there. So it's going to be everything below that. So when x is equal to 1, y is -1/2 and below. So that'll look like that. So that is part of my solution to this inequality. Now let's look at whenever x is equal to 4. So we'll substitute 4 into my inequality, so that gives me y is less than or equal to 3/2 times 4 minus 2. So y is going to be less than 3/2 times 4 is just 6. So 6 minus 2. So y is less than or equal to 4. So when x is equal to 4, y is less than or equal to 4. So let's go ahead and go to when x is equal to 4, which is right here. So when x equals 4, y is less than or equal to 4. So right here is where y is equal to 4. So it's going to be everything below that. So 4 and below. So it'll be like this. And it'll keep on going. So let's go ahead and do when x is equal to -1. So that gives me y is less than or equal to 3/2 times -1 minus 2. So y is less than or equal to -3/2 minus 2. So y is less than or equal to negative 7 over 2. So let's go to where x is equal to negative 1, which is right here. And y is going to be everything below negative 7 over 2. So that'll be down like this. So if we were to do this for every single point, if we were to substitute every single point into my inequality, we'd always get y is less than that, less than or equal to. So I can go ahead and say that everything below this line will be shaded because at each point, I'm going to be going, y can be everything below it. So I'm going to, if I do this at every point, I'm going to end up shading in this entire area. So the area that's shaded will be my solution. And that shows all of the points, all the x and y value, x, y coordinates that I can substitute into my inequality. Y is less than or equal to 3/2 x minus 2. That will make that a true inequality. So what would happen if we were to do this at every point? We would shade everywhere below the line. So whenever we are dealing with a less than or equal to, we're going to be working with below the line. Let's go ahead and look at a different inequality. This time we have y is greater than 3/2 x minus 2. Notice this is just a greater than. It doesn't have the equal to part, and it's a greater than. So what if there wasn't an equal to in the inequality when we're dealing with y is greater than 3/2 x minus 2? So what would be part of our solution? Well, the equal to part of our solution in the previous line, the previous inequality was the line. So what would be part of the solution? The line of 3/2 x minus 2. So that's not going to be part of our solution. But we still have to show where that would be because it's important for our graph. So since it's still important but not part of our solution, we're going to show that 3/2 x minus 2 where it is with a dashed line. So I'm still going to graph the 3/2 x minus 2 normally with a y-intercept of negative 2 and a rise of 3 and a run of 2. But instead of drawing a line, I'm going to use a dashed line to show that my line cannot be part of my solution. And since we're dealing with a greater than, I'll be looking for the y values above my line. So I'll shade everywhere above my line. So the points above my line are the ones that are going to be solutions to my inequality. So where would our solution be according to the symbol? Above the dashed line. So let's go ahead, let's get some solid notes on how to graph these inequalities. Actually, before we do that, one more thing to look at. Let's look at another inequality. Y is less than negative 4/5 x minus 4. We're just going to graph the line right now. Just the line part. And since we do not have an equal to, it's just going to be dashed. So I have a y-intercept of negative 4. I have a slope of negative 5 over 4. I can't go down 4. So I'm going to go up 4. And since I went up, I have to go to the left 5. So give me another point right here. And that'll be my line. And I will use a dashed line since it's just less than. So let's go ahead and plot the point 1, 2. So we're going to go over 1 and up 2. So that's the point right here. And let's substitute those values into the inequality. So 1 is going to be x, 2 is y, so that gives me 2 is less than negative 4 over 5 times 1 minus 4. So that gives me 2 is less than negative 4 over 5 minus 4, which is the same thing as 2 is less than negative 4 over 5 minus 20 over 5, which allows me to combine those easily. So this says that 2 is less than negative 24 over 5, or 2 is less than negative 4 4/5. So, is this inequality true or false? So did this create a true or false statement? So the question is 2 less than negative 4 4/5? And that's false. 2 is positive 2 is definitely not less than a negative number. So that created a false statement. So since that created a false statement, what does that result tell us about where our solution area is? Remember, when we're graphing these inequalities, we're trying to find out the points that are going to make our inequality true. And since the point 1, 2 did not do that, we know that the solution area is not where that point is. So specifically, it's not above the line. So we know it is below the line. So the solution is below the line. So we plugged the point 1, 2 in, and it gave us a false statement. So we knew we did not need the shade there. So therefore, we shade below. Now, if we pick a point that is in the shaded region, so something like negative 5, 5, which is right around this area here. So we know that this should be in our solution area. So let's go ahead and check to make sure that does work. So negative 5, 5, that means I have negative 5 is less than negative 4 over 5 times negative 5 minus 4. And that'll end up giving me negative 5 is less than 0, which is true. So we did shade in the correct area. So now that we know all this, now let's get some solid notes on how to graph these inequalities. So to graph linear inequalities, the first thing we want to do is, just like we're graphing a regular equation, we want to make sure y is alone. So get y alone. Once y is alone, we know what we can graph. But before we do that, we need to check the symbol. So check the symbol. That symbol tells us what kind of line we have and where we're going to shade eventually. So if we have an equal to, we know that we're going to have a solid line. So an equal to means a solid line. And if there isn't an equal to, we know that we have a dashed line to show that the line is not part of our solution. So equal to means we have a solid line. The just a less than or just or greater than means we have a dashed line. Step 3 is to graph the line. So graph the line using the correct type of line, whether that's shaded or dashed. Step 4 is shade the solution area. So if we have a less than, that means we're going to shade below the line. Less than means we're going to shade below the line. If we have a greater than, that means we're going to shade above the line. And then when in doubt, we can use a test point by substituting a point into the inequality. So let's go ahead and graph our first inequality. Y is greater than or equal to 2/3 x minus 1. So y is alone. We can go ahead and skip step 1. Let's go to step 2, and we're going to check the symbol. So we're going to check the symbol. I see an equal to. That means I know I'm going to have a solid line. And I also see a greater than, and that tells me I'm going to shade above the line. So let's go ahead and graph. I start at -1. I'm going to go up 2, run 3. Or down 2 until left 3. And again, since I have an equal to, I have a solid line. And a greater than means I shade above. Let's go ahead and use a test point just to check to make sure we were right. And we're going to use the point 0, 0. So since we think 0, 0 should work, so this should give me a true statement. So I need to find out if 0 is greater than or equal to 2/3 times 0 minus 1. So that'll just give me 0 is greater than or equal to -1, which is true, so we are correct. Let's go ahead and look at the other inequality. I have 4x plus 5y is less than -5. My first step is to get y alone. So I need to subtract 4x from both sides. So that'll give me 5y is less than -4x minus 5. To get y alone, I then have to divide by 5. So I'm going to divide everything by 5. So that will give me y is less than -4/5 x minus 1. I have y alone, so I can check my symbol. I see just a less than, so that means a dashed line. And I see a less than, which means I'm going to be below. Go ahead and graph my line. I have a starting point at -1. I'm going to go down 4 and to the right 5. Have a negative slope, or I can go up 4 and to the left 5. Again, I have a dashed line. And since it is less than, I am going to be below. So everywhere below. So all these points in this shaded area will work for my inequality. Really quick, I'm going to check. This time I'm going to pick a point outside. So I know that the point, I'm thinking that the point 0, 0 will not work. So I'm going to substitute 0, 0 into my inequality. So I'll start with the beginning inequality because we can. So 4 times 0 plus 5 times 0 is less than -5. And since this is not in my solution area, this shouldn't work. So 4 times 0 plus 5 times 0, that's just 0. So this says 0 is less than -5. And since that is false, that means that is not in my solution area, so we shade it in the correct area. So you have a huddle. Go ahead and pause the video. Graph these inequalities. Remember to get the y alone first, then check your symbol, and then go ahead and graph. So go ahead and pause the video and work through these graphs. When you're done, unpause the video to get your solution. These are the solutions to each of these inequalities. The only one that might have been tough to graph, especially the shading area, is this last one. Because it has such a steep slope, it's a little bit harder to see where we would be less than that line. And the way I always try to think of it, if I can't figure out which is less than, which is greater than, I always know less than means I go down. So I go to point my line and I go down. So that can help you find out where you would need to shade. So next we're going to write the inequalities of the graph. So we're going to have to use what we know about writing equations and slope-intercept form, and what we know about the shading and the types of lines that we're using. So here I can see that I am shaded above the line. So I know I'm shaded above. And what does that tell me? Well, since I'm shaded above, I know that my sign is going to be a greater than. I also see that I have a dashed line. And the dashed line tells me that I do have a greater than, but I have just a greater than. So that is the symbol I'm going to use. The next part, I look for the stuff I need to write my equation, my b and my slope. So I can see that my y-intercept is -4. So b is equal to -4. And I can tell that my slope by doing rise over run. So going to this point here, I can rise 2 and run 5. So my slope, m, is equal to 2 over 5. So that will make my inequality, y is greater than 2 over 5x minus 4. The next one, I see that I am shaded below. So that tells me that I'm going to be dealing with a less than. And I see that I have a solid line. And that lets me know that I have a less than or equal to. Next, I find my b. I see that b is 1. Now I need to find my rise over my run. So let's go ahead and go to this point here. That's going to be down 4, so negative 4. And I run 2. So my slope, m, is going to be negative 4 over 2, which will just be negative 2. So my inequality is y is less than or equal to negative 2x plus 1. Last part of the lesson is I want you to tell me if the following points will be solutions to the inequality that is graphed here. And we need to explain why or why not. So we need to first look at the point 1, 1. And we need to find out if it's going to be a solution. So let's go ahead and graph the point 1, 1. So I graphed the point 1, 1, and it is right there. And that is clearly not in the shaded area, so this is not a solution. So no, it's not in the shaded region. So no, it's not in the shaded region. The next point, 0, 2. So I need to plot the point 0, 2 first. And notice it's on my line. But we have a dashed line. And that tells us the line is not a solution. So 0, 2 also doesn't work. So no, the point is on the dashed line. The last point we need to check is negative 2, 3. So let's go ahead and plot negative 2, 3, which will be right here. And if you check, negative 2, 3 is in the shaded region, so yes. The point is in the shaded region. So yes, the point is in the shaded region. So this should get you started well on your homework. Your homework is on the board. Also, it is on Google Classroom. So go ahead and get started on that. Have a good day, guys. Take it easy.